Of the homework that most of you didn't do. Okay, so let me go over this. So this one, 21, what you have to do is realize that this denominator factors, okay? And that factors to 1 over x minus 2 times x squared plus 2x plus 4. Okay, you just kind of have to know that, or you could do synthetic division on it, okay, and with 2 being one of the factors, and this will be the other factor. Now this does not factor, right? Does this factor? X plus, that doesn't factor. So when you rewrite this, this is a linear factor, and this is called a non-repeating quadratic factor. So the way you have to write this is a over x minus 2 plus bx plus c over bx plus c over x squared plus 2x plus 4. Okay? And the way I knew how to factor this is because there's a little formula. The difference of 2 cubes, if this is a cubed and this is b cubed, you could write that in factored form as a minus b, right? This is a perfect cube, right? This is x cubed, and this is 2 cubed. You could write it as a minus b times a squared plus ab, which is 2 times 2, right? Or x times 2, which gives you 2x. And plus b squared, and that's the formula for factoring out something like that. Or you can use synthetic division, and then you have to go through the process and figure out what a, b, and c are. Can you do that? No? Why the heck not? Nolan, quit staring off into space. All right, so who did this? A couple people. You attempted to? So, did you get it factored like this?
I didn't know what the bx was.
Yeah. If it's like this, you have, if it is a non-factorable quadratic, then you have to put a bx plus c up there. Okay? So this one factors like that, and then, so with this one, I'm going to multiply, when I multiply this side, so I multiply this side by this, right? I multiply both sides by the same thing. So I'm going to multiply that by x minus 2 times x squared plus 2x plus 4. I'm going to multiply the right side by the same thing, by x minus 2 times x squared plus 2x, plus 2x plus 4. I'll do one more after this, but not all of them. All right? And then what happens with the a is this cancels out. So on the left side, I just have 1 on the top. And on the right side, I have a times x squared plus 2x plus 4 plus bx plus c times this cancels with that over here, right? So I have bx plus c times x minus 2, right? Okay? So then to find a, you can let x equal something really easy. What can I let x be? 2. X equals 2. So if x equals 2, this whole piece goes away, right? So then I have 1 equals a times 4 plus 4 plus 4. Yes? So a equals 1 divided by 12. Yes? Right? To find b and c, I think what you have to do, you can't really let x equal anything else. What you have to do is multiply this out, okay? So now I know that a is 1/12. That's kind of ugly, isn't it? Okay? So let's leave A alone, and let's write 1 equals A times x squared plus 2x plus 4 plus, and then I'm going to FOIL this, okay? I get bx squared plus cx minus 2bx minus 2c. What?
Why don't you just let x equal
Let x equal what?
0?
Let x equal 0.
So then you have
If I let x equal 0, then I'll still have 2 variables, right?
but you know a.
I guess you could do that. And then you could find b. Okay. Yeah, there's more than one way to solve it. Okay, so if you let x equal 0, b would disappear, you would know a, and then you could find c. That would work. Okay. The other way you could do it is like this: multiply everything out, so you get 1 equals ax squared plus 2ax. That should be a plus sign, right? Plus 4a plus bx squared plus cx minus 2bx minus 2c. That's kind of ugly. But since my only constant term is over here, see that? 2c and 4a, don't I have them? These are constant terms because they don't contain a variable. So I know that 1 has to equate with those 2 constant terms. So I know that 1 equals 4a minus 2c. And over here I found a, which is 1/12. And then I could find c. And once I know a and c, then I could plug in and find b. I know, that's a tricky one, I guess. Okay, I'm not going to finish it. Let's do another one. That took 7 minutes. Let's look at another one. What? Remind me later. Okay, which other one do you want to look at? 27. Okay, whoops, I didn't do that right. Ian, what are you doing back there other than talking? Huh? So this one is a case of, this is a non-repeating quadratic factor. This is a repeating linear factor. So if I were going to write this one in factor form, I'd write it as a over x plus b over x squared plus cx plus d over x squared plus 4. Kind of the problem is figuring out how to write this. If it's a repeated linear factor like this one, you have to write x, because it goes into x squared, and x squared. And then the quadratic factors, you have to have a variable up top. So that's the way you rewrite that one. All right? Well, I'm not going to finish it. I might look at 35. You want me to look at 35?
Yeah.
Sure. Let's look at 35. So with 35, this is a case, this is called a repeated quadratic factor, which is one of the ones I didn't really talk about in class because we ran out of time. But you could have read the book, couldn't you? See that pencil there? You know what that pencil means? You know what that pencil next to the problem means? It means there's an example just like it in the book. All right? It was confusing.
Yeah, but the ones
So
It just had like all kinds of weird
it just had all this
showed,
weird
like,
math.
this, like, really long equations of, like,
Right. X, so you write this as ax plus b, because that's a quadratic factor, x squared plus 4, plus cx plus d over x squared plus 4 quantity squared. That's the way you have to get if you have a repeating quadratic, non-factorable quadratic. Okay? So then I'm going to multiply both sides by this. All right? When I do that, I get, on the top over here, I get x squared plus 2x plus 3, right? I'm just multiplying by this. And over here, I get equals ax plus b times one of these things, right? X, that's an x squared, plus 4, plus cx plus d times nothing, right? Nothing, because that would factor out there, right? Plus cx plus d plus cx plus d, right? Understand that? Well, because if I multiply both sides, what I did there is I multiplied both sides by x squared plus 4 times x squared, excuse me, I just multiplied both sides by that, by x squared plus 4 squared, and that cancels out with that, so I'm just left with that, and that cancels out with one of those, so I'm just left with that. So then the nice thing about this is, let's see, let's write it as x squared plus 2x plus 3 equals, I'm going to FOIL this out, okay? If I FOIL this out, I get ax cubed, right? This times this, plus bx squared, plus 4ax, plus 4b, plus cx plus d. Get that? Yes? So now what you know is that a has to be equal to what? Are there any cubed terms over here? No, so a has to be equal to 0, because there's no, it's like 0x cubed over there, right? So there's no x cubes on this side, so the a must equate with 0. See that? Okay? The other thing, then I look at my x squared terms, okay? All I have is a bx squared, and over here I have a 1x squared, right? That's my only x squared in the whole thing. So what does b have to be? 1, because I have a bx squared, and I have a 1x squared over there. See that? Okay? So I know a and b already. Then all I have to do is look for c. Well, I know that c and 4a, right? C plus 4a has to add up to what? See this? These are my x terms, right? So what does 4a plus c have to be? 2, right? So I know that 4a plus c equals 2, right? And I, what? Because those are the coefficients of the x. See that? Okay? And so 4a plus c has to add up to 2. So, and I already know that a is 0, so c has to be, 2, right? And all I have to do is find d. And d and 4b are the constant terms, because there's no x after them. So you also know that 4b plus d has to add up to this constant term over here, which is 3. See? And so then then what? Then I know b is 1, so I know 4 times 1 plus d equals 3. I know that d equals -1. See? Not so hard. And then I rewrite this with those variables in here. So a is 0, so I just can write this one as b over x squared plus 4. So when I rewrite this, it's 1 over x squared plus 4 plus cx 2x minus 1, because d is negative 1, minus 1 over 2x, that looks like a y, doesn't it? 2x minus 1 over x squared plus 4 quantity